All right, we're finishing up lesson 5 here with cross sections with example 5. Now on example 5, I don't really care for how she has the problem set up. If you look at it, we've got these region bounded by 2 curves. It's set up really nicely to do vertical rectangles, but her problem is set up to do horizontal ones, and I think that's kind of silly. So let's do it with respect to x. So they're going to be perpendicular to the x-axis. Everything else will stay the same. So since this curve always stays on top, it works really well for vertical rectangles. All right, they tell us that the rectangle has a height of 3. That doesn't change. So my area equals base times height. I know my height is 3. So we have 3 times the base. So the base of my rectangle, what would that be? Well, it changes, right, based on where I'm at in my region. But it's always the distance to the top curve minus the distance to the bottom curve, right? It's the place where they overlap. So this one is our top curve, and this one is the bottom curve. So we need to have our area be the height, which was 3, times the top curve, 2 minus x squared, minus the bottom curve, which is x squared. All right, so if we want to find volume, we need to integrate area. Let's take a look where our bounds would be. Since we're doing this with respect to x instead of y, I'm paying attention to my x values, so they intersect at these 2 points. My x value here is -1, and over here it's 1. So we're integrating from -1 to 1. I'm integrating the area, that's what gives me volume. 3 times the first curve minus the second curve. And don't forget your dx on there. I can pull the constant out front. And then we just have these things we can combine together. If you notice, I'm taking a negative x squared and subtracting away another x squared, so we have 2 minus 2x squared dx. Integrate it. Go ahead and pause it if you want and integrate it and see if you end up with the same answer that I do. And look at that, we end up with fractions again. Fun with fractions. When we work all these out, we end up with a 6 minus 2 the first bout, and adding that with a 6 minus 2 on the second bout. And that's going to work out to 8 units cubed, which was the same answer she got doing it the other way. So interesting, we have the same region, same shape for cross section, and so we should end up with the same volume since we're using the same slices to create that volume. All right, the last thing we need to do is finding the general formulas. Sorry, I didn't have my page ready. All right, so how can we kind of condense everything that we've learned into something that's easy to go look at? If I'm given square cross sections, what I need to do is I need to integrate the area of a square, which is going to be the top function minus the bottom function, right? That's how I get my height or my width, depending on which way it goes. So the area is top curve minus bottom curve, and that's a side length, so we would square that to find area of a square. So to find volume, we're simply integrating area from a to b, the 2 functions minus each other, because that was the length of one of the sides of my squares. And maybe it would have been more helpful to start with this. I don't know. You guys can give me feedback on that. Semicircle cross sections. Same sort of concept here. We have the area of the semicircle is going to be pi r squared times a half. The radius is half of this length. So if you look in here, if this is my top minus my bottom curve, we're interested in half that. So the radius is 1/2 f of x minus g of x. So if I want area of a half circle, I have to do half of pi, right, because I'm doing a half circle. And then I'm going to do, so it's 1/2 pi r squared. And remember, r is the 1/2 f of x minus g of x. And don't forget the radius is squared, so we're going to square the radius, which is represented by this piece. So that's our area. We can kind of simplify that down a little bit. We'll get pi over 8 times f of x minus g of x squared. Funny how we ended up with that again, huh? When I integrate this to get volume, you can pull the pi over 8 out front if you so like. We're going from a to b, and again we have f of x minus g of x squared. Kind of a big deal, huh? Showing up again and again. Cool. Last one, equilateral cross sections. So think about your properties of a 30, 60, 90 triangle when you're writing about the area in terms of f of x and g of x. Remember, this is a 60-degree angle, and when I cut the height down in here, I get a right triangle, which means my long leg is going to be square root of 3 over 2 times x or y or whatever is going on there. This distance here is the distance right here between my two curves, so that's always going to be f of x minus g of x. Area of a triangle is going to be 1/2 the base, which we said was f of x minus g of x. Funny how that keeps popping up. Times the height, and in this case the height is square root of 3 over 2 times whatever x or y is going to be, and in this case it's going to be f of x minus g of x. Look at that. So if we clean this up a little bit, we get square root of 3 over 4 times f of x minus g of x squared again. Volume, sorry, I forgot the v for volume, is going to be that cube root of 3, and I forgot the cube root of 3 over 4, from a to b of f of x minus g of x squared dx. Now, I have a lot of students in the past that have said, well, I'm just going to memorize, it's f of x minus g of x squared times square root of 3 over 4, or pi over 8, or 1/2, or whatever. You can do that if you have a great memory, and that's one of your better assets is to memorize stuff. You can certainly do that, but these are all pretty quick to be able to reason through them as well. So don't feel like you need to memorize these. I feel like if you memorize them, what tends to happen is the AP exam throws you something that's just a little bit off, where you'd have to tweak one of these a little bit, and then students don't do that, and they just write down what they memorized, and so they tend to lose a lot of points that way. So as tempting as it is to want to memorize all these and just make up your own shortcut, try to make sure that you're always reasoning through it to make sure that you didn't miss something, okay? Awesome, that is all of Lesson 5. Please take some time to do the homework from Lesson 5, and I will make sure I get you guys the short version of the answer key for that one. Hope you guys are doing well, and I miss you, and I wish we could be sociable, but social distancing is how we save the planet, right?